All right, then we have the function f of x as a piecewise function. It's defined by x times sine of negative 3 over x plus 5 for all x except 0, so for x not equal to 0. And then right at 0, f is defined by some constant that we're trying to determine so that f of x will be continuous everywhere. Right? If you plug in 0 into this upper function, you get sine of negative 3 over 0 times 0. You know, I don't know what that is. What we could do is look at it maybe graphically, and I think that will help. So what we really want to do is figure out what the limit as x approaches 0 of this upper function. We want the limit as x approaches 0 of x times sine of negative 3 over x plus 5, that whole function. We want that limit to equal the y value at 0 in order for it to be continuous. The y value at 0 is this c, so we want that limit to equal c in order for f to be continuous everywhere. Okay, so we have to figure out what is the limit of this function. You're not going to be able to do that algebraically, so you're going to have to do it graphically or numerically. Either way is fine. For time's sake, I'm going to look at the graph. So here's the graph of y equals x times sine of negative 3 over x plus 5. You can pretty clearly see that when x approaches 0, those y values are approaching 5. Okay, as you zoom in. They are oscillating, but the oscillations get smaller and smaller, so they still are approaching 5 right there. So we want the y value at 0 to equal 5 in this case.